Hi guys, welcome to my channel. In this video we are going to analyze the questions about structure analysis. The question will be analyzed due to slope deflection method. Let's analyze the question. First I'm going to specify the fixed end moment. There is fixed end moment from A to B and B to A. Fixed end moment from A to B. That will be equal to WL square over 12. That will be negative because the direction of the fixed end moment. Fixed end moment from B to A, that will be equal to this value, but the positive of that. Let's write the moment equations. I'm going to write here moment from A to B, 2EI over 3 multiplied with 2 theta E plus theta B minus 3 delta over L minus 1.5. This is the moment equation from A to B. Let's write from B to A. 2EI over 3 times 2 theta B plus theta A minus 3 delta over L plus 1.5. And moment from B to C, I'm going to use the modified formula 3EI over 4 multiplied with theta B minus delta over L and of course minus 0. And now you know the moment from C to B is also 0. I'm going to write here, don't confuse about it, 0. And now the two moments at one support, the summation of them must be equal to 0. So this both, the summation of this both must be equal to 0. So what is the summation of them? The moment BA plus moment BC equal to 0. Okay? So here it will be 4EI theta B over 3 plus 1.5 plus 3EI theta B over 4 equal to 0. Because this is fixed, A is fixed, I don't need to calculate the theta E, and I don't have any settlement or any deflection, so I don't need to calculate this also. So in this, from this equation, I'm going to obtain theta B as minus 0.72 over EI, right? Now I obtain my theta B, so now I'm going to write its own place in the equations. So I'm going to write them, and I'm gonna obtain 1.98 kilonewton meter. Okay, and this is going to be 0.54 kilonewton meter, and this is going to be minus 0.54 kilonewton meter. Now I obtain my moments. If I obtain the moments, so let's find the shear forces, and then we are going to draw the moment and the shear diagrams. For A to B, the first member, I have a moment at this direction 0.54, and I have a moment at this direction 1.98. I have a distributed load. When I multiply it with when I multiply the distributed load 2 multiplied with 3 is going to be 6 as a point load, and this is 1.5 and this is 1.5 as the distance. And now let's find the shears. This is going to be VB, and this is also BVA. Okay, so total moment at A is equal to 0, 1.98 minus 6 times 1.5 minus 0.54 plus VB multiplied with 3 equal to 0, right? And VB will be equal to 2.52 kilonewton, and VA will be equal to 3.48 because the total Fy is equal to 0. And when I 6 minus 2.52 minus VA will be equal to 0, and VA 3.48. Okay, it comes from here. So let's write it for the second member. For the second member, this is B and this is C. We have a VC here, we have a shear here. Okay, I have a moment 0.54 here, and the total moment at B is equal to 0. Oh, sorry, this direction positive. I forgot to write here. This direction positive. 0.54 plus VC multiplied with 4 equal to 0. VC will be equal to minus 0.135 kilonewton. And there is no any vertical forces. 1 second. So total Fy is equal to 0 minus 0.135 plus VB equal to 0. So VB is equal to 0.135 kilonewton. Okay. Now I define the shears. Sorry, I determine the shears. So let's draw the shear and the moment diagrams. For the first part, at A I have a shear as 3.48. 3.48, okay? And I have a distributed load. You know the distributed load, if you have a distributed load, it's going to decrease as triangular, right? It's going to decrease as triangular, and it's going to reach 2.52. And this is A, and this is B. This is something like that. And when I write here as X, and this is 3 minus X, because I will need this. When I write something like that as equation, 348 to 52, X is equal to 174. Okay, so now let's draw the moment diagram for this member. This is A and this is B. I have a moment minus 1.98, so 1.98. Sorry. No. 1.98. And from the 1.98, I am going to increase at this amount of area. Okay. When I increase with this amount of area, I am going to reach 1.05. I'm going to reach this amount, and then when I'm going to decrease at this amount of area, I'm going to reach .54. Okay, this is the first part. Let's draw the second part also. For the second part, you know, I have a column, and now I lay it down. Okay, for B and C, I have at B is 0.135 as my shear, and it will continue with the same amount. And when it reaches C, it's going to close by the C, because C is downward direction, and this is also 1305. Okay, and now let's draw the moment diagram. For the moment diagram, I have a moment at 0.54, and I'm going to increase at this amount of area, and this is also 4. When I multiply it 0.135 with 4, and I'm going to obtain 0.54. And when I increase at this amount, and I'm going to reach this point, and this is B, and this is C. This is the moment diagram for the second part. And now the question is that, thank you for watching. If you like these videos, if you want to see more of the videos, please subscribe and share with your friends. Comments. If anything that I did wrong, I am going to revise and make it better. Thank you for watching. See you for the next question.